Hi guys, today what we're going to do is we're going to begin chapter 7 in our notes. We're actually going to go in a little different order. We're going to start with section 7.3, then go back and do section 7.1 and 7.2. And I think it just flows a little better this way. What we're working on this chapter, but it's going to go in order in the packet, so you'll see I started our packet in section 7.3. So what we're going to be talking about is we're going to be talking about confidence intervals. We're going to be creating an interval of numbers, right, with a beginning and an end, to use to estimate the proportion or the average for an entire population of something, all right? So if you want to think about like the general, let's do the general idea of what we're going to find, and then we'll get into a lot more details, right? So if we collect a sample, let's say that we went with that idea of cousins, right? Let's say I asked you guys how many cousins you have, and it comes up that the average is, I don't know, 7.2 cousins, okay? So if we come up with a sample average of 7.2 cousins, and I want to try to estimate for the whole population of teenagers, how many cousins do you have, right? 7.2 would be our best guess because that's our sample mean. But we can come up with a range of numbers. So what we're going to eventually build up to do is we're going to come up with an answer where we're going to have an interval, all right? And the intervals, we're going to be a certain amount of confident with those intervals. So let's say that I crunch numbers, which I'll explain to you later how to crunch them, and I come up with an interval of 4 to 10.4. Okay, I could put mu, the population mean, in the middle, and I can be a percentage confident. You'll see that we're going to get into 90% confident in our answer, or 95% confident, or 99% confident. This is the most confident, this is the least confident. These are our three main confidence levels that we work with. All right, so this here would be your confidence interval, and depending on how confident we are, these numbers will change, and I'll show you how to get these values later, okay? But this is the general idea that we can be a certain percent confident that the true average number of cousins is going to be somewhere between 4 and 10.4. You'll notice one of the key ideas is that 7.2 is right in the middle of that, okay? It's 3.2 down, 3.2 up is going to be with our sample mean right in the middle. We could also talk about proportions, all right? We can do proportions, which is actually what we're going to be diving into today. So if we do a proportion, let's say it's a percentage of students who are going to RCBC next year, right? So we could collect data and run a confidence interval, and I could come up with 0.467. I am just making this up because I have genuinely no idea. Less than 0.603. All right, so we could say somewhere between 46.7% and 60.3% of students will be attending RCBC next year. I could collect a sample of data, get the sample proportion from there, and then create a confidence interval to come up with an estimation for the whole population of Seneca kids and what proportion of them are attending RCBC next year. So now let's come back up to the top and let's break some stuff down, all right? If we're finding all the data values in a population, we call those parameters, all right? That's mu for a mean, sigma for a population standard deviation, or p for a population proportion, okay? Measures that are found using data values from a sample are called statistics, which is why this class is called probability and statistics, because we almost always get data of a sample. It's very, very rare to know the entire population of data, so we don't really use that, okay? Statistics, mu would pair up with x bar, sigma would pair up with s, and p is going to pair up with p hat. I'm not kidding, that's its name, okay? We take a p and we put a hat on it, and that's how that would pair up, okay? So p hat represents your sample proportion. If we want to estimate a population parameter from a sample statistic, then the best estimate of your population mean mu, is your sample mean x bar. That's our best guess, right? If we want to estimate our population proportion, P, then our best thing we can do is use our sample proportion, which is P hat. Okay, now when we use our confidence intervals that we just talked about, we have to have confidence levels. And I told you that these are our three main ones. So now this should look familiar. We have our normal curve back, because our normal curve is going to give us our Z stars. You will notice I put Z with a little asterisk or a little star here. And what we're going to do is when you have these three main confidence levels, we're going to be using Z star in a minute in a formula that we have to work with. Okay, so when we work with that formula in a few minutes, what we're going to have is we need to figure out what this value is. Now, 90% confidence is like saying the middle 90%, which we've done 1,000 times, okay? So you know that symmetrically these are going to be the same Z star, just a positive and a negative, okay? So to find that Z star, if this is 90%, then that means that the rest is 10%, right? 100 minus 90 will leave us with 10%. I'm going to take that 10% and I'm going to cut it in half, and that's going to give me 5% in this tail and 5% in this tail. So to find this Z star, okay, or this one, because they're going to be the same number. So really, let's use this guy, all right? You'll see why later. We want the positive. It's easier to think about. We're going to have inverse norm of 0.95, 0, and 1. You could also look it up on the chart, but I'm doing the 0.95. I'm adding up this whole area. And that is going to give me a Z star each time of 1.645. All right, we're going to round this one to 3 decimal places. This is that one where on the paper chart it lies directly in the middle of 2 different values. So we're going to have 1.645. You will always have the same one. 90% confidence is this Z star every time. Just grab a Post-it note, stick it on there, and use it. Just throw the Post-it note in your notes and you can have it. Okay, if the problem calls for 95% confidence, then if we have 95% in the middle, it's going to get like a little wider, right? It's okay if you didn't draw it wider, but it's going to get a little wider than it was up here because it's a little bit bigger percentage inside, which means we have 5% left over. Cut that in half, you get 0.025 in each tail. So this is 0.025 and this is 0.025. So to get our Z star this time, we're still going to use inverse norm, but it's going to be 0.975, right? Add those together, you're going to get 0.975, 0 and 1, and you will always have a Z star. 95% confidence is going to give you a Z star of 1.96. So you can add that to your Post-it note. 95% confidence, 1.96. 99% is going to have 1% left over. Cut that in half is 0.005. which means there's barely any area in each of these tails. Okay, so when we go to find the Z star for a 99% confidence interval, you're going to have inverse norm of 0.995, 0, and 1. Remember, I just added together this area to get the right Z score. Okay, and then that gives you a Z star of 2.58. Now, so add that to your Post-it note. You will see like the problem in a second when we get to the problem. The problem is going to only give you one of these 3, right? So it's going to tell you like this percentage, 90% confident or 95% confidence or 99% confidence. So whichever one of these it tells you, that tells you which one of these Z stars to use. Okay, and where the Z star comes into play is right here. Okay. When we deal with proportions, then we're going to have this interval here. P hat is your sample proportion minus whatever the Z star is in the problem, right, depending on what we were given. And then it's going to be a square root of P hat times Q hat over N. An important thing to note is that P hat and Q hat add up to 1. All right, so then you're going to subtract to get the Q hat. And as we go through the problems, I'll talk you through the whole thing, and we'll like just kind of start exploring, okay? And just keep in mind that we want to round to at least 3 decimal places when we're dealing with proportions. So, example 1. A sample of 500 nursing applicants for a nursing program at a large university included 60 men. We want to find and interpret the 90% confidence interval of the true proportion of men who applied to the nursing program. So, when we work on these problems, we need to figure out p hat. Okay, p hat is what we're looking for. We're looking for the proportion of men. 60 divided by 500 is the proportion, right? Okay, so that's our sample. So based on this sample, can we predict what the proportion is for the whole population? All right, so 60 divided by 500 is 0.12. We're going to use the decimal. It's a 0, so you don't have to put the 0, right? But so it's just 0.12. Q hat is 1 minus p hat because they add up to 1. So 1 minus 0.12 gives me 0.88. The other pieces of information I need are n. N was 500 because you need the n right here. And then we need z star. So z star comes from the first page that we just did. If it's asking for the 90% confidence interval, 90% confidence means z star is 1.645. So you're going to have 1.645. So now as we look at this equation, it's p hat minus z star, big square root p hat q hat over n, less than p, less than p hat. Notice it's the same on the right. These are identical, except I'm changing the minus to a plus. That's the negative z star and the positive z star that we had on the thing, on the chart on the previous page. So it's going to be p hat q hat over n. So p hat was 0.12 minus 1.645, big square root 0.12 times 0.88 over 500, less than p, less than. You're leaving the symbol p here. We're trying to estimate it. Remember back here? I left mu in the middle and I left p in the middle. Well, today we're working just on proportions for the next couple of days. Okay, so if I leave p in the middle, now I'm going to have 0.12 plus 1.645, big square root 0.12 times 0.88 over 500. All right, now when you put this in your calculator, because that might look daunting, right? And that's okay. If that looks daunting, that's okay. So what we need to do is we need to get to like a calculator page. Okay, so when you get to a calculator page, we're going to type in our equations. So we're going to type in just the left. Okay, so you're typing in just this stuff, but you're going to type it in one shot. Don't go piece by piece by piece. It's much safer and more reliable. So we're going to go 0.12 minus 1.645 square root, fraction inside the square root. Remember, control divide gives you the fraction. And you're going to do 0.12 times 0.88 over 500. Okay, and you're going to press enter, and there's our answer, 0.096. Less than p, less than. Now, you could choose to type this in. You could also choose to use that method I show you where you go up twice, and then you press enter and you bring it down, and then you can tab backwards and change the minus to a plus. Whatever you prefer. Be careful, this is not 0.143, the 9 bumps it up, so this is 0.144. Okay, this is our interval, which means that we can be, and we're going to write sentences, and I'm going to help you guys. We can definitely talk about that, but we're going to write sentences to describe what we're finding, right? Half of this class is number crunching. Half of the class is describing what those numbers mean, right? So we can be 90% confident, because that was our confidence level, that the true proportion of men who applied to the nursing program or the applicants that were men is between 9.6% and 14.4%. All right, I just switched them over to percentages because I think it's a little easier to look at. All right. So this is our interval. This is the description of our interval. And then the last thing that it asked was, what is your margin of error? Your margin of error is how wrong you could be, like the width of the interval. It's not this minus this. Remember, your p hat, your 0.12, is going to be directly between these two numbers. Okay, it's like literally right in the middle every time. Whatever your sample proportion is going to be the middle of those numbers, because then you're adding and you're subtracting. So this amount here is your margin of error. Okay, it's how much you could be right or wrong, like the above and the below. So to find that, what you can do is you can actually subtract these guys and cut it in half. Or you can just take like the top number, because it'll give you a positive, and to find your margin of error, we call it ME, you can take your top number, 0.144, and subtract your sample proportion, your 0.12, because that's where it'll be, right? That's the 0.12, and how much do you add and how much do you subtract to get to these n numbers? It's the same amount. So 0.144 minus 0.12 is 0.024. So it's a 2.4% above and below your sample proportion. That would be your margin of error answer. So for part B, what we're going to do is we want to find and interpret the 95% confidence interval. Everything else is the same. So P hat is the same, Q hat is the same, N is the same, but 95% means our Z star changes. And if our Z star changes, what happens? It becomes 95%. If you go back to the first page, you will find that your Z star is 1.96. So you're going to have 0.12 minus 1.96, big square root, 0.12 times 0.88 over 500. Less than P, less than. Same thing on the right, but we're going to add the 1.96 this time. Big square root, 0.12 times 0.88 over 500. Okay, put this in your calculator right now. Try. Put the left in. You should be getting 0.092. Less than P, less than. Put the right in. You should be getting 0.148. Okay, that's your interval answer. Now, interpret. So it said find. That's our find. Interpret. Interpret is the sentence. We can be 95% confident or certain that the true proportion or true percentage of male applicants was between 9.2% and 14.8%. Notice it got a little wider, right? This was 9.6 to 14.4. We got a bigger confidence level, and it got a little wider. It went a little farther right and a little farther left. So when you find your margin of error, the 0.12 of P hat is still right in between these two numbers. So we can still use the same idea. Take your top number and subtract your P hat. Whatever notes you need to jot down for yourself, go ahead, jot them down. This time we got 0.028 for our margin of error. So this was find your interval. This was interpret your interval. This was find your margin of error, the wiggle room, the above and below. Alrighty, so let's tackle one more problem. Okay, a survey of 200,000 fishing boat owners found that 9% of the fishing boats were named Serenity. We want to find and interpret the 95% confidence interval of the true proportion of boats named Serenity. So, jot down your info. N equals 200,000, huge sample size, okay? P hat, our sample proportion, already gave it to us. It's 9%. So how do we write 9% as a decimal? 0.09. Okay. Q hat would then be 1 minus 0.09, and we would get 0.91. Now, be careful. Back here, we had to divide. We were given 60 out of 500. Divide that down, you get the 0.12, 12%. This is, they just gave you 9%, so it's just the 0.09. Okay, it can go either way. Our Z star, if we're working with 95% confidence, that means that Z star equals 1.96. Okay, so go ahead, plug it in the formula. You have all these formulas on your formula card too, by the way. So you might just want to, this is definitely like, bring that back, okay? And you've got them all there. So we're going to have P hat minus Z star, big square root P hat, Q hat, over N, less than P, less than P hat, plus 1.96, big square root, same stuff inside. Okay, so go ahead, put this in your calculator. All right, check your work. So we're going to 0.09 minus 1.96, big square root, fraction, 0.09 times 0.91 over 200, boom. We're going to get 0.089. And then we're going to just go up and we're going to change it to a plus. And we get 0.091. This is also one of the big reasons why you have to do at least 3 decimal places, right? It's okay if you do a fourth, but you have to go at least 3. If you only did 2, it'd be 0.09, less than P, less than 0.09. That doesn't make any sense, okay? Here, right, we can be 95% certain that the true, and I'm just going to pull right out of the problem, the true proportion of boats named Serenity, I forgot the word true, here we go, proportion of boats named Serenity is between 8.9% and 9.1%. Okay, what's your margin of error? Take the top number, subtract your P hat, 0.001 or 0.1%. Okay, great job today. We will pick up with more later. I hope you took really great notes.